this is the hazard tool. Everybody's familiar with it, and this was used in a BCA for a safe room. Just so that you all can see, that's my frame of reference. And now I will start my presentation, which I prefer not to go in the presentation mode because I think it'll be quicker if I just move down the slides. So I've been around ASCE since 1988. That's when I became a member. COPRI about 2002. I'm the chair of the Waterways Committee, and I've done a lot of different things over my career that gave me insight to do BCAs. I never thought I would be doing BCAs. I was always just looking to be an engineer in a family of engineers and contractors. But you know how life is. One thing led to another, and here I am. So, what I found interesting, if you all can see my screen, I'm just seeing Dan on the screen, by the way. So I'm
Yeah,
not
I
sure.
see your slides, so I
Okay.
think we're fine.
Okay. So, you know, what is surprising to me, and I'm not sure that others are aware of this, but BCAs have been around a long time, and they really go back to this fellow right here. I couldn't even tell you how to say his name other than Saint Pierre. But in the early part of the 1700s, he ran the first benefit cost analysis. And then he was followed by another Frenchman, Mr. Dupuy, who was assigned by one of the Napoleons, and I'm not sure which one, but he looked at the sewer system in Paris. And so this is a timeline. I will share this with everybody. I'll get it to Megan so that everybody can have a copy of this. But this gives you a timeline from 1708 from Saint Pierre through Dupuy and all the different things that the French did. And then, of course, we have our own timeline in the United States. Uh, I believe the gentleman on the left was Secretary of State. Let me make sure of that Secretary of the Treasury in 1808, and then ending with James Watt, who was the head of the Water Resources Council, and that's a timeline of that, and that's when the Corps basically during Roosevelt years they created the Green Book and they had to run benefit cost analysis really as a result of the Flood Control Act of 1936. And then that evolved into, you know, the principles and guidelines that the Corps uses in their water resources. And so that's where the BCA started in our country. And they were on independent parallel tracks with France, but it did uh, verify that it was a sound science, if you would, in evaluating the merits of a project. So I'm just going to quickly go through this. I have a lot of slides and we are time sensitive, but basically I always say this, the rule of thumb is you look at your benefits, you look at your cost, and then you have your benefit cost ratio. And you always want to have roughly a 1-to-1. You want to have a little more than that, but that is a rule of thumb. And really, the toolkit that FEMA developed, I see John spoke earlier and is on. I think FEMA's done a great job with the toolkit. The toolkit is the easiest part of a BCA. It's all the work that goes into it in the background. Um, as they say, as shared by our NOAA colleagues, you have the window, you have the back of the house, and you have, you know, the actual shopping center itself where the product is laid out. So the work is done in the back of the house. And this is just these are basic, fundamental, you know, concepts of what the benefit cost ratio is. What makes a project cost effective is that it has to have a greater than 1-to-1 benefit cost ratio. Some of the things that have changed in the toolkit, one is the discount rate. Discount rate basically says that $1 today going into a project is worth more than $1 down the road. And so it was for many years 7% with the FEMA toolkit. But the Corps, I think since the 1974 Water Resources Development Act, has been arguing with OMB that it should be around 3%. And indeed, that is where the entire country is now as of last year, 3.1%. So one of the concepts in doing BCAs is net present value. So you want to, the sooner you invest in an asset, I know everybody's seen the chart about deferred maintenance. That a dollar you put in today is going to cost you $4 or more down the road. And this is very similar. And we experienced it over the last 4 to 5 years. Just to go back to my background, I was just a regular engineer doing design work locally here in Louisiana. And before the pandemic, I joined a firm that was under contract with the state arm of all the FEMA funding, called GOSEP. And I reviewed probably 1,500 BCAs and built BCAs from the ground up, several hundreds, I would say. And one of the things that kept happening during that tenure, I was basically an extension of staff for the state, was the pandemic was driving the construction cost up. That's what we kept telling the sub applicants. And today, by the way, I work for GOSEP still, but with the sub applicants, trying to get them to get their projects in the ground. The sooner you get it in the ground, the better chance that you're not going to have this runaway construction costs. And that's what the net present value is all about. So this conventionally, the BCA was always based on Circular A-94 of OMB. And when they came out with the ecosystem services guidance out of OMB, they looked at this circular and another one, A4. And we're going to go quickly through these slides, but these are just the fundamental concepts of how the BCR is calculated. You have to look at not just the cost of the project, but the maintenance of the project. Yeah, and then there is the discount rate, and there is also inflation built into the FEMA toolkit. And so this is just a cross section of a breakwater in front of a barrier island with a dune, and it could be a living breakwater. And now these are the type projects that are allowable under FEMA funding, both for HMGP, which is disaster related, and BRIC, and FMA, which is non-disaster related. And the toolkit calculates the benefits for these project types. One of the things that we do in the back of the house is the loss avoidance calculations. And that basically is taking a look at a model output of future water surface elevations at different return intervals, say 10, 25, 50, 100, 500 year events. And we put that surface in a building layer and look at the damages to those buildings, and we calculate the damages. That would be our pre-mitigation condition. And then we put the project in and see how the water surface elevations are lowered, and then we calculate the damages again. And that's what creates the benefit cost ratio, basically. That is called the avoided loss, and there are other parts to the BCA. It could be utilities, it could be not just property damage, in other words. And so these are some of the other, I would say, inputs into the BCA. You could have a loss of electric power, potable water, wastewater, etc. And then, of course, they do monetize fatalities, hospitalization, treat and release, and self-treat. So the other part of the BCA that I find is very interesting, and I think there's a lot of work that could still be done in this area, is social benefits. And it has to do with mental stress and anxiety and loss of productivity as a result of floodwaters. So even if your house hasn't flooded, but if you can't go to work, it creates stress and loss of productivity to the economic impact to the entire community. So that's calculated as well in the BCA. These are the expanded ecosystem benefits that have been added over the last couple of years. They used to just have coastal wetlands, inland wetlands, riparian areas, but they have expanded it into marine and estuary, um, coral reefs, shellfish reefs, beaches and dunes, etc. And I think that has been a great there's been a great deal of progress in that regard and actually quantifying those benefits. So there are some things that you can include in a BCA, and that's what these slides are going through. One of them is, the reduction in flood insurance. That's not something that we would calculate as part of the BCA. So what are the costs? The cost would be the construction-related costs, maintenance, any added contributions from the subrecipient. Even if a grant only has $20 million and the subrecipient puts in another 20 million, the BCA has to look at the total amount of the cost for the project. So again, what can't be considered is reduced tax base, indirect economic losses, transfer payments like insurance premiums, etc. And what is the project useful life? The BCA toolkit has some default values for that, if it's a concrete structure, etc. And so it's provided in the help tabs of, which is an icon with an I, information, that you can click on when you're in the toolkit. And this particular project right here is in St. Bernard Parish, which we're going to look at the bottom. It's a shoreline protection and marsh creation project. And then the other parts of the BCA, you can either do a model-based BCA, a professional expected, or a historical data-based BCA. And if you're looking at modeled, as I mentioned, you could do a 10-year, 25, 50, 100-year. You basically are looking at these water surface elevations for each event before and after to calculate the damages. Basically, the BCA is taking a damage and converting it to a benefit through the project. A lot of engineers that I work with still have a difficult time understanding that, and I try to press upon them that it's very important that they do understand how to derive benefits from their project, because that determines whether it gets funded or not. So a lot of times when they're building their H&H model, they're not necessarily taking that into consideration. So these are the different flood control projects that you would use: dams, culverts, flood stream restoration, drainage improvements, etc. This, by the way, is a polder in Lafourche Parish, and there's a floodgate. We're going to go over that project at the end here, and that's the floodgate. And so these are this is the discussion on whether it's could be a historical based or a professional expected based BCA. And again, I think I'm sort of repeating myself, but these are just the damage. What drives the BCA are the damages before versus the damages following the mitigation project. So to the toolkit, to the hazard tool, one of the things that I mentioned to Dan, and I've met with several other members of the task force, it would be nice to go to one place. I go to the hazard tool to pick the wind out, so that I could put that in the BCA for a safe room, a wind retrofit, etc. It would be nice if we had storm surge in there. We had other riverine flooding models. FEMA produces what they call base level engineering riverine modeling. So here's the toolkit. This is the example of a safe room. That's where they're going to put this particular safe room. Basically, you just put in the Latin long and you put in the class, the risk category, and you look at the different wind, the return intervals for the different, the wind for different return intervals. And then you just plug that right on in. Here's the toolkit. This is a modeled damage based BCA for a safe room. And I just pick off those numbers out of the hazard tool, and I plug it in, and there's other inputs that's provided by the subrecipient, and in this case, it was cost effective. So earlier this year, but it was coming over the last couple of years, OMB finally formalized guidance for ecosystem restoration or ecosystem services as part of the BCA process, or nature-based, as some people may call it. So the overview of this is the overview of the guidance, and it was following these two executive orders, 14072 and 14094. And this was the justification for it. They looked at, like I said, circulars A-4 and A-94 from OMB. And this was the purpose of it. It was basically to quantify the benefits of nature-based solutions. And these are the definitions of those different categories. And so the guidance, it basically gives you, it lays out how you should do the work in the back of the house. You do the proper scoping for the analysis with the baseline conditions or regulatory alternatives, assessing the benefits and the costs correctly, doing a distributional effect, uncertainty analysis, and then how you would present that as backup. This particular project is a shoreline protection, marsh creation. It's I think there are 4 phases of the Lake Leary restoration program, and which is carried out by the state. And this was phase 3. So this is the hardening of the shoreline and then the back marsh behind it. And the benefit area is much of the east bank of St. Bernard Parish, which is shown and delineated in that figure. And then this is a tool that I made in GIS, which I think is what I'm talking about, that could be brought into the hazard tool. All of those little blue dots are that's the coastal transect data. That's from AdCirc modeling. It gives you the 50, the 100, the 500 year water surface elevation. The light blue shaded area, that's the where you can see right here. Can you see my cursor?
Yeah.
Okay. This is the shoreline protection, the larger phased. It's a multi-phased Lake Leary restoration program, and the project in question here is right here. And so these are all marsh creation projects in the darker blue, and then the orange dots here are all repetitive loss, severe repetitive loss properties. And then if you see a little black outline, it's hard to see. I do have it on the screen, which we can pull up later, but if needed. But those are mitigated properties. And so this tool, I think you could put some of this on that tool, on the hazard tool. The AdCirc modeling was a collaboration between the state of Louisiana, the Corps of Engineers, and FEMA. And FEMA is the final say, by the way, especially when you use their money to build the project. So that's
Hey, Dennis, can I interrupt you just for a second?
Sure.
I know, because I was long-winded at the top. You're running. You started a bit late, but like maybe 5
I'm almost
minutes.
done. Yes, sir.
Okay,
I'm almost done. I'm right at the end. And this is the input to the BCA, the damage years, the damages, and with the return in them. The toolkit has a little storm frequency calculator in it, and it calculates a return interval if you use a historical based BCA. And this is how it's entered into the toolkit, and it's pretty straightforward. And those are the damages, which were shown in the previous table. And this is the ecosystem services. We use coastal wetlands, 100%. It was about 400 acres. And it was we used the entire population of the benefit area, and it really performed well as far as benefit cost ratio. It was over a 60-to-1 just without social benefits. This last one is on Bayou Lafourche. There's the polder. It's a typical Louisiana rural community that is transect with waterways and highways and commerce in the bayou, if you would. And so there's a lot of risks there, and they have floodgates all around them and levees all around them. And these are the water levels that were used as input into this BCA for this floodgate and the impact to the navigation channel. And so again, this is the input that was used in the BCA. This is the BCA itself. It came out a pretty healthy BCR as well. And this is what that area looks like. This is on this floodgate. These are all the damages in the area, and you can see the storm surge all around them. They literally are an island. That's called the LaRose Golden Meadow polder. And here is the output from the BCA. And really, that's all I had, Dan. I did manage to get through it, and happy to take any questions. And I feel like, again, I feel like one of the things that would be beneficial to a user like me of the hazard tool is to have more layers in it. And one of them would be storm surge. One of them could be riverine flooding, etc.
All right. Thanks, Dennis. Questions for Dennis? Well, I always have one.
I have one.
All right, go ahead, Yvette.
Yeah, I'm trying to understand, I think I heard you say that the model takes into account, it takes into account mental loss of the individual, but it won't
Yes.
allow you to take into account unemployment and loss of income. I find those to be conflicting.
Well, you have to talk to John and his superiors about that. But no, the BCA, it's driven. It's a regulatory driven tool, as you know, and I think it's a good topic to bring up. I'm trying to find that particular slide, and how they quantify these standard values is intriguing to me as well. But I cannot. Let's see. Can you see this particular slide? Mental stress and anxiety, $2,443 per person. Loss of productivity, $8,736 per person.
Right. Well, I think about what Dan said earlier about, working at the community level and trying to kind of get to the micro level, I think to make the business case for any community, their lack of tax base matters, and somehow we have to figure out how to quantify that into our models.
Yes, ma'am. Good point. I agree with you 100%.
So, Bilal, go ahead.
Yeah, thank you. I can't find raise hand thing. Sometimes it disappears on me. But thank you so much, Dennis. That's a very good presentation, and I really appreciate showing the recent information from OMB and so on. But my question is about the uncertainties. I mean, obviously the benefits it's not a single number, but it's uncertain. So if we have an estimate, it's our best estimate, but we need to maybe, ideally, we should have some spread around it, reflecting the epistemic or whatever uncertainties that we have. And the same thing with the cost. I mean, we all did projects where we know that the cost also, especially when you deal with ecosystem projects and so on, they could be quite uncertain of what we need to do. And again, we could have a best estimate, but also a variance. I think what I've done in the past, and I have that covered in my risk analysis in engineering and economics book, is to treat both the benefit and the cost as random variables. And then we could talk about what's the probability that the benefit will not be realized. So in other words, what does that mean? It means that I could maybe favor a project that will have a lower benefit to cost ratio than a project with a higher benefit to cost ratio because of the uncertainties of being smaller in the former compared to the latter. So the uncertainty dimension, I think, is something that needs to be. I know it's not mainstream at the present, but that's an item which is essential that we need to promote. Thank you. But what you've done offers a very strong foundation for this added, pursuits, maybe in the future. Thank you.
All right. Thanks, everybody.
They did
All right.
mention uncertainty analysis in that guidance, by the way. And but
Yeah.
I'm with you. I think that there's not enough backup to what some of these values, what are they based on, and how. I always think about maintenance is a big uncertainty, especially when you're talking about nature-based solutions, because who's gonna maintain it? And whereas not concrete, if it's concrete, it's a different maintenance schedule than, say, something that is soft like a marsh. So anyway, I hear you. And Dan, I know you're pressed for time, so
No. We're actually fine. I think we're going to forego the break. If anybody needs a break, they can take one. Because I do want to talk a little bit about. I mean, obviously, you have a lot of experience in coastal Louisiana, and that's where many of your examples come from. And these are fairly large Army Corps of Engineer projects. So I've got a couple different questions. One is, all of these costs and benefits, do they take into account future conditions? If the design life for a water diversion project, et cetera, is 30 to 50 years, does it take into account like what's the future sea level rise going to be? I know it takes into account the cost of money, and that's accounted for at least. But I'm more curious about, we spend a lot of time talking about future conditions. How is that handled in this, if at all? And then the other part of it is, you have multiple projects taking place in one basin. How do they interact with each other? So those are the two questions I wanted to just throw out there.
Yeah, I'll take the second one. It's an easier one. They do not want you to duplicate benefits. So it's very important that you clearly, and we do this all the time, where they may be two projects in the same watershed from two different disasters, and they're covering the same real estate. They're a little different, but and we get poked and prodded about duplication of benefits all the time. One way to segregate is to have different return intervals also for those projects. So and you can it really gets down to the model. The model needs to account for the other project, couple them together, have them independent, because FEMA is not just looking at cost effectiveness. They're also looking at, are they going to create any downstream impact? So they have to have a cumulative impact analysis of all the projects, so that they don't flood other people out, trying to keep the flooding from the area of concern. So that's one thing. As far as sea level rise and the performance of a particular project, as far as the toolkit, the only area where we add in sea level rise is when we're doing elevations. And they're also, these are mostly for coastal areas, but they have a methodology now on the impact of climate change to riverine systems, and that's been out for a couple of years. And so you can add to the base flood. Um, as far as on large scale, like drainage projects, flood diversions, that kind of thing, that's going to be accounted for in the modeling. So the modeling will have a baseline, and they'll have not just a future with and a future without, but they'll also have a sea level rise element in there. And I'm assuming they would have the same in a riverine system. I haven't seen that yet.
All right, thanks, Dennis. Sihan, you have the last word.
Okay, sounds great. Thanks, Dan. I get two questions, Dennis, for you. One is related to the vulnerability curve part, which is, I think, a part of the system you have. A lot of times we're discussing the uncertainty from the hazard, but the vulnerability curves that basically drives the federal monetary losses has also a lot of uncertainty, just because those curves are oftentimes developed by very generic structures or something, you would say. But if we're in the large assessments, there are a variety of different structures, infrastructures that might not perfectly fit in their one particular vulnerability curves. I'm just wondering whether the system has some kind of quantification of the uncertainties that has built into there to consider the uncertainty from the vulnerability side. The second question is related to, one is BCA analyses carried out, whether there are some terms that often used by insurance or reinsurance companies to quantify the monetary loss, like the annual maximum loss or annual aggregate loss, or the cumulative losses, or the risk at tail, something like that. So from your practices and experiences, what is more important for the BC analysis, whether it is the annual loss risk, or it is the lifetime loss would drive up the BCA in most scenarios, or it's case dependent?
Oh, you're on mute, Dennis. Sorry.
I apologize. I hope that my answer is appropriate. So in the first case, when we're calculating damages, we're looking at depth damage functions. So we're and Jesus and the Corps has their HEC module that calculates damages. There's some sort of cross pollination between the two, by the way, and the toolkit. And I don't know exactly how the inner workings of that work. But what we do as a BCA specialist is we get from the modeler the water surface elevations at each property within the drainage basin, and for each return interval, and we use the most up-to-date depth damage function to calculate those damages. Does that answer your first question?
Yeah, so if I understand correctly, you would use a set of specific information to correct or develop a damage function for each property?
Well, the damage functions are already been derived, and it's been through a series of studies that the Corps has done, and in cooperation with FEMA.
Right.
And that's what we use. That's best available to us.
Okay.
And the model itself is going to, as we discussed earlier, it's going to include future conditions, which may include climate. So if it's just strictly riverine, there's a method that you can use to calculate the increase in the water surface elevations. If it's a coastal environment, there's a sea level. We usually pick the intermediate projection, by the way.
Right. Okay.
Okay. And then
Yeah.
the second question was on the, remind me what the second question.
Well, the second question is related to whether the annual loss or the
Lifetime.
loss would be more important for the BCE calculation?
Well, the what from our chair, and I have to tell you, I mean, I keep my blinders on. I don't try to challenge too much of what is accepted in the industry, because our job is to get the project approved. That's what we want to help the sub-applicant do, so they can get their project funded. There's a lot of flaws in it, and we could spend a lot of time on that. There's a lot of error in this work, and what is acceptable, so the calculator itself does annualize damages, but what the decision makers to fund or not fund really gets down to whether it's cost effective or not, and whether the input into that BCA is sound. It has error in it, just like every model has error in it, and you have to have good judgment and experience to know when something is right or wrong. I mean, and how many times have we thought we were right, and then we have a storm that proves that we were wrong? So it happens all the time. But I hope I'm answering that question correctly for you as well. I don't, as far as the decision makers, they care about whether it's cost effective, and then they're going to ground truth to back up into that BCA. And you can look at annualized damages, but that is not a factor on their decision. What's a factor on their decision is whether it's cost effective, which means a greater than 1-to-1 benefit cost ratio.
All right. Well, thanks, Dennis. I appreciate your time and effort here. I think we have a lot to learn about the space.